Decades before the Harrier or the Osprey, Tesla patented an aircraft that rises straight up, then flies like a plane. Here is how, in his own words. The airplane's fatal flaw: it cannot take off slowly. The utility of the aeroplane as a means of transport is materially lessened and its commercial introduction greatly hampered owing to the inherent inability of the mechanism to readily rise and alight, which is an unavoidable consequence of the fact that the required lifting force can only be produced by a more or less rapid, translatory movement of the planes or foils. In actual experience, the minimum speed for ascension and landing is a considerable fraction of that in full flight, and the principles of design do not admit of a very great advance in this respect without sacrifice of some desirable feature. For this reason, planes of very large area, high-lift wing sections, deflectors of the slipstream of the propeller, or analogous means which might be helpful in these operations, do not afford the remedy sought. This indispensable high velocity, imperiling life and property, makes it necessary to equip the machine with special appliances and provide suitable facilities at the terminals of the route, all of which entail numerous drawbacks and difficulties of a serious nature. So imperative has it become to devise some plan of doing away with these limitations of the aeroplane that the consensus of expert opinion characterizes the problem as one of the most pressing and important, and its practical solution is eagerly awaited by those engaged in the development of the art, as well as the general public. Many attempts have been made to this end, mostly based on the use of independent devices for the express purpose of facilitating and ensuring the start and finish of the aerial journey. But the operativeness of the arrangements proposed is not conclusively demonstrated and, besides, they are objectionable, constructively or otherwise, to such an extent that builders of commercial apparatus have so far not considered them of sufficient value to depart from present practice. Why the helicopter looked like the answer. More recently, professional attention has been turned to the helicopter, which is devoid of planes as distinct organs of support and, presumably, enables both vertical and horizontal propulsion to be satisfactorily accomplished through the instrumentality of the propeller alone. However, although this idea is quite old and not a few experts have endeavored to carry it out in various ways, no success has as yet been achieved. Evidently, this is due to the inadequacy of the engines employed and, perhaps, also to certain heretofore unsuspected characteristics of the device and fallacies in the accepted theory of its operation, an elucidation of which is deemed necessary for the clear understanding of the subject. The prospects of a flying machine of this kind appear at first attractive, primarily because it makes possible the carrying of great loads with a relatively small expenditure of energy. This follows directly from the fundamental laws of fluid propulsion, laid down by W.T.M. Rankine more than 50 years ago, in conformity with which the thrust is equal to the integral sum of the products of the masses and velocities of the masses and velocities of the projected air particles. From these relations, it is evident that a great thrust can be obtained with a comparatively small amount of power simply by increasing the aggregate mass of the particles and reducing their velocities. Taking a special case for illustration, if the thrust under given conditions be 10 pounds per horsepower, then a 100-fold increase of the mass of air, accompanied by a reduction of its effective velocity to 1/10, would produce a force of 100 pounds per horsepower. But the seemingly great gain thus secured is of little significance in aviation, for the reason that a high speed of travel is generally an essential requirement which cannot be fulfilled except by propelling the air at high velocity, and that obviously implies a relatively small thrust. And why the helicopter fails? It plunges and flips. Another quality commonly attributed to the helicopter is great stability. This being apparently a logical inference judging from the location of the centers of gravity and pressure. It will be found, though, that contrary to this prevailing opinion, the device, while moving in any direction other than up or down, is in an equilibrium easily disturbed and has, moreover, a pronounced tendency to oscillate. It is true, of course, that when the axis of the propeller is vertical and the ambient air quiescent, the machine is stable to a degree. But if it is tilted even slightly, or if the medium becomes agitated, such is no longer the case. When the helicopter is tilted, the machine will fall along a curve to a level below, and upon reaching the lower layer with a high velocity relative to the medium, will be urged further down along the curved path, and the kinetic energy, in the vertical sense, possessed by the moving mass, must be annihilated before the fall is arrested in a still denser air stratum. At this point, the upward thrust will be far in excess of the opposed pull of the weight, and the apparatus will rise with first increasing and then diminishing speed to a height which may approximate the original. From there, it will again fall, and so on, these operations being repeated during the forward flight, the up and down excursions from the main horizontal line gradually diminishing in magnitude. In this connection, it may be pointed out that an adjustable aileron will not act in the manner of a rudder, coming into full play at intervals only and performing its functions economically, but will steadily absorb energy, thus occasioning a considerable waste of motive power and adding another to the many disadvantages of the helicopter. Let now the machine be possessed of a certain degree of freedom, as will be the case normally, and observe in the first place that the blades of the propeller themselves constitute planes developing a reaction thrust, the pressure on the lower leading blade being greater than that exerted on the higher one owing to the compression of the air by the body of the machine, and increased density in that region. As the axis is tilted more and more, the vertical sustaining effort of the propeller will correspondingly diminish, and the machine will fall with a rapidly increasing velocity, finally exceeding the horizontal when the reaction of the blades will be directed upward so as to increase the angle and thereby cause the machine to soar higher. Thus, periodic oscillations accompanied by ascents and descents will be set up which may well be magnified to an extent such as to bring about a complete overturn and plunge to earth. Another very serious defect of this kind of flying machine, from the practical point of view, is found in its inability of supporting itself in the air in case of failure of the motor, the projected area of the propeller blades being inadequate for reducing the speed of the fall sufficiently to avoid disaster, and this is an almost fatal impediment to its commercial use. From the preceding facts, which are ignored in the technical publications on the subject, it will be clear that the successful solution of the problem is in a different direction. Tesla's fix: rise straight up, then fly like a plane. My invention meets the present necessity in a simple manner, without radical departure in construction and sacrifice of valuable features, incidentally securing advantages which should prove very beneficial in the further development of the art. Broadly expressed, it consists in a novel method of transporting bodies through the air, according to which the machine is raised and lowered solely by the propeller and sustained in lateral flight by the propeller and sustained in lateral flight by planes. To accomplish this, a light and powerful prime mover is necessary and as particularly suited for the purpose I employ, preferably a turbine of the kind described in my U.S. patent number 1,061,206 of May 6, 1913, which not only fulfills these requirements but is especially adapted to operation at high temperature. I also make arrangements whereby the flying machine may be, automatically or at will of the operator, caused to function either as a helicopter or an aeroplane. Inside the machine, tilting seats and a turbine. Full knowledge of these improvements will be readily gained by reference to the accompanying drawings, in which Figure 1 illustrates the machine in the starting or landing position and Figure 2 in horizontal flight. Figure 3 is a plan view of the same, with the upper plane partly broken away. The structure is composed of two planes or foils, one rigidly joined. Their length and distance apart may be such as to form a near square for the sake of smallness and compactness. With the same object, the tail is omitted, or, if used, it is retractable. The motors in this case turbines of the kind described in my patent before referred to, and other parts of the motive apparatus are placed with due regard to the centers of gravity and pressure, and the usual controlling means are provided. At rest, the planes are vertical, or nearly so, and likewise the shaft driving the propeller 3, which is constructed of a strength, size, and pitch that will enable it to raise the entire weight with the motors running at an even greater rate than when propelling the machine horizontally. Power is transmitted to the shaft from the turbines through suitable gears. The seats 4-4-4 for the operator and passengers are suspended on trunnions, 5-5, on which they can turn through an angle of about 90 degrees, springs and cushions being employed to ensure and limit their motion through this angle. At the start, sufficient power being turned on by suitable means, the machine rises vertically in the air to the desired height, when it is gradually tilted by manipulating the elevator devices and proceeds like an aeroplane, the load being transferred from the propeller to the foils as the angle of inclination diminishes and the speed in horizontal direction increases. Simultaneously, with the tilting of the machine, the operator will increase the thrust of the propeller in order to compensate for the reduction of sustaining force. And by suitable manipulation of the apparatus and gradual cutting down of the power developed by the prime mover, as forward velocity is gained and the planes take up the load, he may cause the machine to advance horizontally along a sensibly straight line, a condition essential to the attainment of the best practical results. In descending, the forward speed is reduced and the machine righted again, acting as a helicopter with the propeller supporting all the load. Owing to its extreme simplicity, the motive apparatus is reliable in operation, but should the power give out accidentally, landing can still be easily affected by volplaning. For this purpose, in addition to wheels 9, 9 and 10 wheels 11 are employed, the latter being mounted on the forward end under the lower plane, and so that when the machine rests on level ground, the propeller shaft will have the desired inclination, which is deemed best for rising in the manner of an aeroplane. Such an aeroplane, constructed and operated as described, unites the advantages of both types and seems to meet best the requirements of a small, compact, exceedingly speedy, and yet very safe machine for commercial use. The biplane seems to be best suited for the chief purpose contemplated, but the invention is applicable to monoplanes and other types. To sum up, the helicopter type of flying machine, especially with large inclination angle of the propeller axis to the horizontal, at which it is generally expected to operate, is quite unsuitable for speedy aerial transport. It is incapable of proceeding horizontally along a straight line under the prevailing air conditions. It is subject to dangerous plunges and oscillations, and, what is most important from the commercial and practical point of view, it is almost certainly doomed to destruction in case the motive power gives out. These drawbacks and defects are overcome by the methods and apparatus I have described, through which a novel type of flying machine may be realized, possessing all the advantages of the helicopter, being at the same time safe and capable of a speed equal to or even greatly exceeding that of the present aeroplane. What Tesla claimed, the first tilt-rotor aircraft. What I desire to secure by letters patent is 1. The hereinbefore described method of aeroplane transportation, which consists in developing by the propelling device a vertical thrust in excess of the normal, causing thereby the machine to rise in an approximately vertical direction, tilting it and simultaneously increasing the power of the motor and thereby the propeller thrust, then gradually reducing the power and thrust as forward speed is gained and the planes take up the load, thus maintaining the lifting force sensibly constant. During flight, tilting the machine back to its original position and at the same time increasing the power of the motor and thrust of the propeller and effecting a landing under the restraining action of the same. 2. the method of operating a helicopter, which consists in varying the power of the motor and thereby the thrust of the propeller according to the changes of inclination of its axis, so as to maintain the lifting force sensibly constant during the forward flight. 3. The above described method of transporting from place to place a heavier than air flying machine, which consists in applying power to the propeller while its axis is in a vertical position sufficient to cause the machine to rise, tilting it and at the same time applying more power to increase the thrust, then gradually diminishing the power as the load is transferred from the propeller to the planes, tilting back the machine, and so controlling the planes tilting back the machine and so controlling the applied power as to affect a slow descent upon the landing place under the restraining action of the propeller. 4. In the transport of bodies by aeroplane, the method of controlling the propeller thrust and reaction of the planes by varying the power of the motor correspondingly with the inclination of the machine so as to maintain the lifting force sensibly constant during the forward flight. Please like and subscribe if you would like more content like this. Thank you.